yeah, I think we can, well, the recording is already started, but maybe we can just go ahead and start the session. Nice. Thanks. So welcome everyone to FOCIL Breakout number 11, I think. Yes. Today we're going to have a presentation by Michael on relay inclusion lists. Before this, just want to tell you about the few updates related to FOCIL. Yeah, first, I think I mentioned it last time, but we are planning the FOCIL session during the Berlin Interop, which is going to be in June, exactly on, wait, let me check exactly the day. It's going to be on Wednesday, the 11th, I think. So for those of you who are around, you are, of course, invited. And just DM me and let me know, and I'll just like tell you the exact time and location. Most speakers have like confirmed, and basically the sessions are going to be on FOCIL implementation progress. We're going to have one that's going to be by Jihoon, one on FOCIL synergies with other EIPs. That's going to be by Francesco. We're going to have one on FOCIL and statelessness by Carlos, one on ZK FOCIL by Benedict, one by FOCIL and the future of nodes by Barnaby. So I think that's going to be very exciting to just like talk about all these in person. And yeah, if you're around, just join us. I think it would be fun. Yeah, about like the FOCIL synergies, another update is like sort of like the progress made on the interaction between FOCIL, delayed execution, and block access lists. It's nice because basically if you have block access lists with post-transaction values, that mostly allows attesters to statically validate blocks and especially like the FOCIL conditions in a much like simpler way than before. So I mean, Tony and Francesco, I think I'm mostly working on this. I've been just like following along and providing inputs, but yeah, it's just like nice to see that a couple of like different EIPs actually make it easier for each other. So that's something I think we need to follow up on. But yeah, I think it's just like nice. Yeah, just also wanted to highlight one of Vitalik's posts about the local node favoring delta to the scaling roadmap. I recommend checking it out because it's actually quite related to VOPs, so validity only partial statelessness, something we presented during a previous breakout room. And you know, in the comments there are like sort of like a lot of discussions and back and forth on the future of FOCIL and what FOCIL can be like and how it interacts with full native account abstraction. So yeah, if you have opinions or want to comment or participate in the discussions, you can check it out there. Other update, I think it's also nice to highlight when new people join like Discord conversations, and it's been the case lately. So yeah, it's just like great to have like more and more people engaging on this and like asking questions and being curious about FOCIL. So if you have any more questions, you can also ask them during this breakout. And yeah, I think that's mostly it for me. Are there any questions on any of these small updates? No. Then we can go ahead and with the presentation. So I think, yeah, it's going to be Michael on relay inclusion lists.
Yeah, hi guys. We are sharing our screen. I should be in a second. Okay, just to confirm, can you guys see the screen?
Yeah.
Okay, perfect. So first of all, thanks for the opportunity to present our design here today. Relay inclusion list, we have a post up on ETH Research, and thanks also to everybody that provided feedback on this design. We can also then continue the discussion on ETH Research. There's already some good exchange of ideas going on there. But in any case, without further ado, let's jump in. So the agenda for the presentation is to first quickly describe the goals of relay inclusion lists, specifically what we want to achieve here. There's 3 goals, and we'll walk over them first. Then to sketch out the design, that is the architecture of the system. And then there's basically 2 more or less discretionary dimensions, which we'll deep dive separately. And the first of those is what transactions to include, so the inclusion rule. And then the second is how many transactions do we include, which is the sizing question, the size of the inclusion list in terms of network size, so bytes specifically. And then lastly, we want to talk quickly about the future directions. So the design goals, well, first, we want to use relays to immediately improve censorship resistance. And we want to do this in a certain aligned way. First, we want to avoid introducing protocol changes or other technical complexity which would make the design forbidding. So specifically, our goal is to have something that could be applied tomorrow and immediately start increasing censorship resistance, adding value in this type of transparent way. We also don't want to introduce qualitatively new trust assumptions. What that means is that relay inclusion lists can be accomplished by the existing actors in the PBS pipeline, and validators wouldn't need to trust somebody new. They also wouldn't need to make a decision if they trust somebody more, right? So basically, the relays that they would be using, these would be the relays that would start delivering relay inclusion lists. And lastly, one thing I want to highlight, we ideally would like to see relay inclusion lists as a baseline. So this should be a new default feature for non-censoring relays, where the validator may opt out if it really desires that. But generally, for a non-censoring relay, it should be building relay inclusion lists by default. Now, the second goal of the design is to prepare the block production pipeline for a future in-protocol inclusion list. Put a different way, relay inclusion lists are not a substitute for in-protocol inclusion lists. We see them as a logical step in this direction and a quick step. What that means in practice is, first, we want relay inclusion lists to roughly reflect the FOCIL specifications. And the way we would like this to reflect is that the risks of the design are incremental, right? There's something that's rolled out step by step, there's testing, and it's done off-chain. And then this would result in a seamless operational rollover to FOCIL. If I put it in practical terms, if in-protocol inclusion lists come about, builders, relays would know how to coordinate on such a list being built. And this is not just technical, this is also things like bidding dynamics. And then lastly, we want to achieve these 2 overarching goals in a sustainable way, right? And which means that the relay inclusion list at the beginning should preserve relay competitiveness, or put another way, propose a risk reward. Okay? And one thing that means is what I mentioned initially, no additional load on the proposer. And then secondly, block value should not be meaningfully decreased, right? Because if the relay inclusion list were very large and would add a lot of latency, and the block value were to decrease, this would just make the relay less competitive. And in this way, timely inclusion, would kind of decrease over this separate axis of just the relay not winning the slots. But we think we have a good way of approaching all 3 of these goals. Yeah, the design overview, you see it sketched out on the right there. And again, one goal for this is to be quick, and that means it needs to be transparent and simple. There's basically three steps, and they're preceded by a setup, which is that non-censoring relays by default should build relay inclusion lists for all proposers with that optional opt-out. Now, once the setup stage has been completed, what would happen is for each slot, the relay observes the mempool and then ranks these transactions via a deterministic inclusion rule, assigning a score to each. And the inclusion rule is something that will be discussed on the next slide. So I will skip that part for the moment and instead focus on the general setup. Then once the relay has derived the weighted the list of transactions ranked by inclusion score, it would fill the inclusion list with the respective top ranked transaction until the relay inclusion list size limit has been reached. And then lastly, once the list has been built, the relay would expose a API endpoint that builders can use to fetch the inclusion list. So this is part one at the beginning of the slot. And then there's part two, which is after the builder has seen the inclusion list and has started to has reflected it in its block. So this is when the builder delivers the block. Then the relay simulates the execution. So first, the relay checks if all transactions in the inclusion list are included in the block, and if a transaction in the inclusion list were not included in the block, the relay would simulate its execution against the block's post state. And then if any non-included transactions pass standard pre-execution validity checks, the block is invalid and rejected, right? So this is a strict condition. Thirdly, if a builder is optimistic, the relay might not be able to reject the block in time. Instead, what would happen is there would be a penalty enforced against the builder. And the way we propose handling this penalty in our research post is that it should reflect the block value, because factually the block would be forfeited. There's another question that came up in previous discussions, which is what happens if the builder's block is already full. This would not be a scenario that we would be concerned about at the moment, because the builder would have the list of transactions in the inclusion list available at the beginning of the slot, and therefore should, as part of standard procedure, sort it into its block, which means that the block wouldn't be full without the transaction on the relay inclusion list being included. Now, the next thing is the inclusion rule. So we are quickly summarizing two options here. Option one, which, by the way, thanks for that, Anders has proposed on ETH Research, is a lot leaner than option two. I kind of refer to these options respectively as multiplicative without normalization, that is option one, and normalized and additive, which is option two. For option one, I'm not going to deep dive both of them right now, but I'll just quickly summarize it, and then we can examine it in more depth, maybe in the discussion afterwards or on ETH Research or async. Option one basically computes the inclusion score over the waiting time of the transaction in the mempool and the priority fee of the transaction as a multiplication of each attribute. Optionally, there could be a weight added for each attribute. For example, if we were to want to say that the priority fee is more important than the waiting time, we could reflect this. But initially, we would assume that the weights are zero, or put another way, that they're equally important. And the logic behind this is that we say, inclusion, this happens over a time axis. So we wouldn't want the transaction to sit in the mempool forever. But it is also a function of how quick the transaction wants to get in, which is the priority fee component. And then the inclusion score that will have been derived would be adjusted by the total gas paid per transaction. Put another way, we would want to maximize the space that is still available in the inclusion list. It's worth highlighting here that the inclusion list is measured in network terms, so in kilobyte, but the final adjustment here would basically be saying, well, the block space has to be maximized in terms of value. Then there's option 2, which is normalized and additive. Again, one key difference here is multiplication of the waiting time and the phi, or addition of the waiting time and the phi score. The implication of multiplication is that a transaction which has a priority phi of 0 would not find inclusion, whereas with addition, this would be the case. Then for the addition rule, we would again begin by examining the waiting time and the priority phi, and we would normalize it by the median waiting time or priority phi for all transactions pending in the mempool. Then we would compute a simple additive score and divide that by the byte size, which would be a way of maximizing over the networking constraint. So to quickly summarize the slide here before we go further, the difference between these two rules would be multiplication or addition, which is a statement of, does a transaction that only needs to, that only pays the base fee, should that transaction find inclusion? It is also a way of kind of handling manipulation resistance in different ways. Multiplication without normalization has some spam resistance built in. And again, transactions are compared to each other in both scenarios. And then the inclusion score by total gas paid or by the transaction byte size, this would be an implied statement over what the bottleneck is, right? Is it block space or is it networking? Where the byte size would be on networking and then block space would be measured in gas. Generally, our feeling is that these are both appropriate ways of approaching it. We find option 1 quite lean and elegant, but generally we would see this as a discussion kind of with the stakeholders, and then we can come to a final decision from there. The next point, or the next kind of parameter decision, is the sizing of the inclusion list. And there's basically one overarching goal here, which is that the size of the inclusion list shouldn't really meaningfully affect block value, or put another way, decrease block value. And the context here is that block value decreases with increased latency, and then latency, of course, scales with the size of the inclusion list. This kind of foreshadows the point that I made at the beginning, which is that relays providing relay inclusion lists must stay competitive, right, to ensure timely inclusion, and to ensure the design finding continued validator adoption, which is the reason why we initially propose a shelling point, which is the constraint proposed in the FOCIL specs, which is lean. With that said, relay inclusion lists have a big advantage over proposer-driven inclusion lists, which is that they're not constrained by the proposer bandwidth, right? Which is the second point on the slide here. And what that means is, as relay inclusion lists become more adopted, they can support larger sizing. One reason for this is that the opportunity cost of opting into relay inclusion lists decreases for the more relays run it, and therefore they can be larger, right? Because you don't have to compete with relays that opt out of relay inclusion lists on latency. If everybody competes on the same terms, it's possible to raise the size without incurring cost. And the second thing is the bit curve can shift to accommodate the marginal latency that relay inclusion lists add. So basically, if I know that the block will be sent around a little bit earlier, I can provide my best bit a little bit earlier. And then just to wrap it up, we think there's some promising future directions here. And first of all, multi-relay inclusion lists. What this would mean is there could be a shared inclusion list that can be built from the inclusion list computed by multiple relays. One advantage of this is that it improves censorship resistance by enforcing uniform application of the inclusion rule, right? So there couldn't be a single relay which kind of builds the inclusion list to maximize its, for whatever goal it might be pursuing. There's a lot more assurance that the inclusion rule is applied consistently. And then because it is also the same for each relay, the playing field would be even. And then secondly, if each relay builds an inclusion list only locally, there's a chance that builders want to keep a lot of optionality, right? So they might build one block for relay A and another block for relay B. Under multi-relay inclusion lists, they would build one block for all relays, which reduces redundancy and then again also unlocks some efficiency in this way. The other two directions, we see relay inclusion lists for blob type transactions. And lastly, what we mentioned before, larger relay inclusion lists. To conclude the slides, there's some further reading here. The first is the EVE research post, which I would encourage people interested in this idea to consult. And then the post has a couple of references that we make, all very interesting reads, which are listed below it. So I would suggest checking this out too. Yeah, so that's it from my end.
Great. Thanks a lot. That was really cool, and yeah, very nice to see that you guys have worked on the inclusion list side of things for relays. Also, that the work on FOCIL was useful to build that up. It's very nice to see. I have quite a lot of questions, but I want to give the opportunity of other people to ask some first. So if anyone has some, go ahead.
Sorry, just a random question. I want to know, could the relays prioritize certain transaction, like inadvertently introducing new centralization risks, like relays becoming gatekeepers or something like that?
Yeah, sure. So this is something that we want to avoid, and there's two key steps that have to be taken to avoid the relay kind of making these discretionary decisions. One is the inclusion list inclusion rule has to be very simple. So there's not a lot of room for discretion, right? So the relay applies it, each relay applies it in a way that is uniform. And then secondly, one of the future directions we outlined, which is relays talking to each other, that helps with that too. Because if relays collectively decide on the final inclusion list, then individual relays have a lot less power to kind of skew the list into a direction which they would prefer.
Oh, okay. And one last thing, is there like a possible interaction with proposal build separation, especially if the builders ignore relay list to maximum MEV?
Yeah, so I mean the entire design is like purposely built such that it fits onto the current PBS supply chain. And so yeah, the intent is just to communicate these constraints or the inclusion list to the block builders, and they have to adhere to it. So unless there are relays that don't support it, basically for a given slot, if a proposer connects to these relays, a block will not be valid. So it essentially is purposely built for the PBS supply chain as exists today.
Nice. Okay, I will go ahead with some of mine. Yeah, this is more of a comment, but just wanted to point out that the FOCIL size is 8 kilobytes, but there are like 16 of them. So, if there is no overlap, that will actually be 16 times 8 kilobytes. But I know bandwidth is a concern. I just wanted to sort of like make that clear. I also like that was in your last slide, but but blob ILs would actually be really, really cool. It's more bandwidth for sure. I think it's actually around the side of like 16 times 8 kilobytes for one blob, but FOCIL doesn't support this in its current form. We have ideas of like protocol ways to get better censorship resistance for blobs, but it's really not there yet, at least like not at the same stage as FOCIL is. So yeah, I mean, I think that's a very exciting direction. And then yeah, there was more comment, but if you have any answers.
Yeah, so quick comments on the blob ILs. So as you said correctly, the biggest concern is just the size and the additional latency, and hence preventing adoption or like putting relays that basically adopt this like in a worse spot in terms of competitiveness.
Yeah.
That being said, we're currently already exploring optimistic v3 for relays, which essentially means that the builders can submit the headers without submitting the payloads, which effectively means they can, like on a low latency basis, keep updating their bits without having to shuffle the entire big block payload. And so under optimistic v3, the size of the block, at least from a latency perspective, in terms of submitting bits to the relay, should have zero influence. And once that is live, I think basically blob inclusion lists also become viable.
Nice. Okay, that's pretty cool. And makes sense for sure for the size of it. Also, yeah, I understand the gradual process into making sure you have some adoption before you increase like the bandwidth for sure. Nice. Does anyone have any other questions? Otherwise, I'll just keep going. Okay, I'll keep going. Yeah, just wanted to know for the inclusion rule. I think I didn't get why the multiplicative regime didn't have the transaction size as an input and the additive did, because the transaction size is not only like I don't know, an optimization, it's also to avoid that also allows to avoid the IL flooding. Like, you can, if you submit like a very, very large transaction that gets picked up and that takes like the entire inclusion list, and then you are able to invalidate it, that sort of like crowds out other transaction, and that's an attack we want to avoid. So like sort of like filtering by descending order by transaction size is anyways a quite good idea, I think.
Yeah, thanks for the comment there. I think this is very valid. So basically, there's two things we considered. One is where in option 2 we are adjusting by transaction size to kind of preclude this vector that you mentioned, right? Where a single transaction can come in and clog up the space on the inclusion list. And then the angle from which we approached the other adjustment in option 1, which is over the gas, is we were saying, well, what do we expect to be the bottleneck in practice? Would it be the networking constraint, or would it be the block space constraint? So kind of which of these is more limited, and then we should maximize over the constraint. The option with adjusting by gas to some extent also favors smaller transactions if we say that they have less gas, but of course in a less direct way. I think in summary, we don't really have a final intuition yet on which of these approaches would be best, but it seems like there could be a hybrid approach there, where we adjust by both to some extent, or we have a threshold to ensure that this attack where somebody can clog up the block space does not happen, but at the same time we maximize the utility of the remaining block space.
Nice. Yeah, that makes total sense. And there is also Anders' comments on ETH research apparently that compares these options. So I will look into this a bit more. Thanks. And then more general, I think, high-level questions. What will happen to relay inclusion lists if, or let's be optimistic, when FOCIL makes it in the protocol?
Yeah, I think from our perspective, then it would just be deprecated. What Michael mentioned earlier, I guess the upside of having some of the actors across the supply chain already supporting inclusion lists is obviously builders will have adopted them, but also the relays in terms of having to validate blocks based on inclusion lists and things like that. But like actually gossiping or like needing to maintain and generating the inclusion list will then, from our perspective, currently be deprecated.
Okay, yeah, that makes sense. No, the rollout makes total sense. I was just sort of wondering, okay, what happens? Because then it will feel a bit like a double, like, I don't know, repetitive sort of thing.
Absolutely. I think like in protocol is obviously much stronger. And so like, yeah, there wouldn't be any need anymore.
Okay, nice. Thanks a lot. Any other questions from other people? Or should we move on?
I have a question. How do we make sure relays build relay inclusion lists according to the inclusion rule correctly? What I want to ask is there any gadget that prevents relay inclusion list doesn't become a vehicle for breakout?
Yeah, so to summarize the question, if I understood it correctly, was how we ensure that relays apply the inclusion rule correctly. I think one way we've approached this is by saying the relay is a trusted party and the validator enforces this trust against the relay. So if a relay were to misbehave, ideally the validator should opt out. And then secondly, once the relay inclusion list can be shared between multiple relays, so multi-relay inclusion lists, the last point on the last slide, this vector would be offset to a large extent because then relays build one inclusion list collectively, again, reducing the discretion each individual relay has over the inclusion list.
Yeah, and the other factor is that given that the inclusion list will be made available publicly, which is how the builders will, or which is how they will be communicated to builders. If there's any massive outlier, i.e. Some weird transactions that were never seen on the mempool start ending up on the inclusion list and things like that, I think builders will pretty quickly spot it and call relays out. And then again, it will be a huge reputational damage, which I think is one of the key things that relays optimize for.
Got it. Thank you.
Right, thanks. I guess another sort of like out of the box idea is like to use a T, but might be a bit of overhead. And I agree about like the trust assumption being sort of the same. Like if you trust the relay, you could also trust it for building inclusion list according to the rules they have specified. But great. Okay, thanks. Yeah, again, great presentation. Thanks a lot for coming in. Should we move to implementation updates? I don't have any super specific thing on the agenda, but I am curious to hear if there are like sort of progress across the board, whether it's testing or implementation on clients or interop. What's the status of all this?
Yeah, I can say a couple of things. First, I think we should try to get this PR authored by Mark merged in as soon as possible. I think there's been a lot of comments on that, and I think it's okay if we just want to like limit scope and open a subsequent PR as long as we address kind of like the core aspects of what's happening on the execution layer. And then, yeah, I have a draft PR up on the execution specs. We'll need to do a rebase on top of the latest Osaka fork over there, which didn't exist at the time that I opened it. And then I'll have to, yeah, depending on what gets merged into the EIP, maybe make some changes. I've also been working on the execution spec test. Should have a PR up in the next few days. Again, this is another thing where it'd be nice to have this PR for the EIP merged. Just so we're all operating from the same EIP essentially. And then yeah, once that's ready, we'll be able to have some test fixtures in the engine new payload format. And then yeah, I will validate those with either Reth or Geth. The Reth or Geth fossil fork before the PR, and then other clients can consume them and validate them. But yeah, I think the main thing is just try to get the PR merged in the next day or two would be great.
Can I take a look through these review comments today?
Great. Appreciate that. Yeah, that's all I have.
Nice. No, that's awesome. Yeah. I remember there was quite a bit on the PR, but I haven't looked for a while, so I'm happy also to take another look today, see if I see anything, and yeah, agree we should get it merged. Because I did see new people coming in also and being a bit confused about the execution part of the EIP, so would be nice to have it merged. I agree. And then what I just didn't really follow what was the sort of like first PR, not the spec test one, but the first PR was about that you need to rebase on Fusaka.
The execution specs. Yeah, I can share a link to that PR. But essentially it's just, taking what's in the EIP and
Yeah. Thanks. Perfect. Okay, great.
making it so that we can create test against it. And yeah, just a more formal version of the IP, or at least the execution layer aspects of it. However, yeah, the diff shown is quite large because I had to add a bunch of Osaka boilerplates, but now that there's a upstream branch with that, should be able to remove a bunch of that.
Nice. Yeah, that's awesome. Okay, great. Thanks a lot. And you have been talking to the Steel team, right?
Some, yeah. Yeah, I mean, fortunately, they have some pretty good docs, and I was able to figure out most of these things myself. But yeah, they've been helpful and responsive, so it's great.
Okay, great. Okay, very good news. Thanks for sharing. Okay, any other updates?
Yeah, so on the consensus spec side, I'm working on consensus specs and consensus spec tests. I've added basic unit tests, and there were some missing pieces in the spec. So that's what I'm currently working on at the moment. After completing the spec, I can resume adding a bunch of tests. And the fixtures will also provide inclusion lists as a file so that CL clients can consume it. Timeline-wise, Justin and I aim to ship it in the next consensus spec release, if it's possible, which is in 2 weeks.
Okay, sounds good. Great. Okay, so it's awesome because you guys are like sort of like working in parallel on both the consensus execution side of things for tests, which is really cool. Yeah, let me know or let everyone know, I guess, if you need input on ideas or things to test at any point. I feel like there are quite a lot of scenarios we can actually sort of play around with on both sides. But maybe, yeah, I know we are not necessarily there yet, but would be nice to also chat about this. And then, does anyone else have something to share? Okay, if not, yeah, June.
Yeah, so I just remember that there was a feedback that there was a discrepancy between the overview picture of the EIP and the text below, and it'd be nice if we could align them. So maybe, yeah, Joe Chen, do you want to talk about it more?
Yeah, it was just something I noticed when reading the EIP. So I think if the text and the picture matches, then it is also much easier to understand, because now it looks yeah, a bit contradicting when you read the EIP.
Okay, yeah, I remember seeing that in the discussion for sure. I can take a look very soon. Let me just make a note of it. But yeah, no, that's a good point. We'll definitely look into this. Thanks. Then Mercy, you want to talk about what you shared?
Yeah, I started working on the front end of the transaction visualizer. It's still empty though, but I was hoping to try and populate it and see what the transactions and how it's going to actually look like. But this is where I'm at the front end currently. But the back end is mostly ready, yeah.
Nice. Okay, super cool. Thanks. Nice. And then let me check. I remember I wanted to ask a client team that was very, very close to, yeah, I think there was Lighthouse. I remember Lighthouse being very close to interrupt and then sort of like not hearing from you guys. Do we have someone from Lighthouse here? No. Okay. Yeah, we'll just follow up with them later, I guess. But great. Okay. Is there anything else? Okay, cool. Then I think we can end this. Thanks a lot for joining and participating, and see you in 2 weeks.
Thank you.